Hello, my name is Justice Morgan.
My name is Sandra Ohadawa.
My name is Eli Obas.
My name is Jamie Robinson, and we will be presenting Section 8.2 through 8.6 on the gas laws.
Hello, my name is Jamie Robinson, and I will be presenting Section 8.2, Pressure and Volume. Boyle's law is a principle that describes the relationship between the pressure and the volume of a gas. You use this principle to determine the final pressure or volume when the temperature and amount of gas are constant. The formula for Boyle's law is P1 times V1 equals P2 times V2.
Now we are going to demonstrate Boyle's law through a problem. Cyclopropane is a general anesthetic. A 5-liter sample has a pressure of 5 atmospheres. What is the volume in liters of the anesthetic given to a patient at a pressure of 1 atmosphere with no change in the temperature and amount of gas? So first you want to set up the equation for what you're looking for. So you're looking for the final volume, which is V2. So you set up the equation by dividing both sides by P2, which gives you V2 equals P1 times V1 divided by P2. Then you look for what you're given. So you're given for P1 5 atmospheres, for V1 5 liters, for P2 1 atmosphere. After you find out what you're given, you plug it into the equation that you found for V2. So you plug everything in. So for P1 you have 5 atmospheres. For V1 you have 5 liters. For P2 you have 1 atmosphere. So you would do 5 times 5, which gives you 25, and then divide that by 1, which gives you V2, which is 25 liters of cyclopropane.
Next, we will talk about 8.3, temperature and volume. Charles' law describes the relationship between temperature and volume when pressure is constant. We use Charles' law to determine the final temperature or volume when the pressure and amount of gas is constant. The formula for Charles' law is V1 divided by T1 equals V2 divided by T2. To demonstrate Charles' law, we will work a problem. A balloon contains 2,500 milliliters of helium gas at 75 degrees Celsius. What is the final volume in milliliters of the gas when the temperature changes to 55 degrees Celsius? So first we want to set up the equation. So remember, Charles' law says that V1 divided by T1 equals V2 divided by T2. So we're trying to find V2. In order to set up the equation, you need to multiply both sides by T2 to put V2 by itself. So V2 equals T2 times V1 divided by T1. From there, you plug in the variables into your equation. So T2 is 55 degrees Celsius, V1 is 2,500 milliliters, T1 is 75 degrees Celsius. Once you solve the equation, you get 1,833.33 milliliters. But because the original equation has 2 significant figures, you need to change your final answer into 2 significant figures, which gives you a final volume of 1,800 milliliters of helium gas.
Hello, my name is Sandra Ohadawa, and I did Section 8.4, which covered Gay-Lussac's law. Gay-Lussac's law states that the temperature of a gas is directly related to its pressure. There's 2 formulas you can use. You can use P1T1 equals P2 over T2, or P1 times T2 equals P2 times T1. The number of moles of volume must be constant when you're calculating for Gay-Lussac's law. And the temperature also must be in Kelvin. So if it's in degrees Celsius, you're going to have to convert it to units of kelvins. If an aerosol can of hairspray has an initial pressure of 1.4 atmospheres at room temperature at 23 degrees Celsius, but is heated to 50 degrees Celsius, what is the final pressure in atmospheres? First, we need to rearrange the formula so it fits the standards of this question. Now that we've plugged everything in, we can go ahead and solve. These 2 units will cancel out and we'll be left with our atmosphere. And the final answer will be rounded to 2. And 1.30 atmosphere will be our final answer.
My name is Eli Obas, and I had section 8.5 combined gas law. The combined gas law it consists of Boyle's law, Charles' law, and Gay's law. The equation is P1 times V1 over T1 equals P2 times V2 over T2. What's so special about combined gas law is that you can deprive it or omit certain elements to show separate gas laws. For example, Boyle's law, you can see it in P1 V1 equals P2 V2. Yeah. For Charles' law, if you eliminate the P1 and the P2, you can see it's V1 over T1, which is Charles' law, and V2 over T1. I mean V2 over T2. And for Gay's law, you can eliminate the volume on both sides, and you can see P1 over T1 equals P2 over T2. This particular law, it states the ratio of the product of a pressure and volume and absolute temperature of a gas, which is equal to a constant. Alright. Here's a question that's been presented to us, and we're going to find a way to explain it. During laparoscopic surgery, CO2 gas is used to expand the abdomen to help create a larger workspace. If 4.8 liters of CO2 gas at 18 Celsius at 785 mmHg is used, what is the final volume in liters of the gas at 37 Celsius and at a pressure of 745 mmHg? Yeah, so the first step to solving this problem would be to identify your initial and your final terms. Alright, so the formula we're going to use is P1 V1 over T1 equals P2 V2 over T2. If we go back to the problem, you will see that it says in the beginning, if 4.80 liters of CO2 gas at 18 Celsius at 785 mmHg, those are your first initial terms. So you will plug that in right here, make a little chart to help you see. P1 equals 785 mmHg, V1 will be equal to 4.80 liters, and T1 will equal 18 Celsius, but you'll have to add by 273 to convert it to kelvins to put it in the formula. It will equal 291. Then after that, you will go to your final steps, and you'll find out that P2 is equal to 745 mmHg, and we're trying to find the volume of the final term, and T2 equals 37 Celsius, and you add that by 273, and you'll get 310 kelvins. Once that is completed, your second step is to get the variable that you're trying to solve, to get it by itself, and you simplify it. So the variable we're trying to solve is V2. So once you get it simplified, V2 equals V1 times P1 over P2 times P2 over T1. And once that is simplified, you will substitute all the information that you gathered before right here into your equation, simplified equation. You will enter V1 as 4.8 liters, and you will plug in 785 mmHg over 745 mmHg times 310 kelvins over 291 kelvins. After that, once you formulate all that and calculate, your answer will be 5.39 liters.
Hello, my name is Justice Morgan, and today we will be talking about Avogadro's law. Avogadro's law was formulated by Amadeo Avogadro in 1811. The law states that the volume of a gas is directly related to the moles of a gas when the temperature and pressure are constant. The formula is V1 over N1 equals V2 over N2, or V1 divided by N1 equals V2 divided by N2. Let's say you were blowing up a balloon. As you were blowing air into the balloon, the volume of the balloon increased as the air you blew into it increased. So if you popped it, the amount of air would decrease and the volume of the balloon would decrease. The balloon would get smaller. This is an example of Avogadro's law. Now let's look at an equation concerning Avogadro's law. So, a sample containing 4.80 grams of O2 gas has an initial volume of 15.0 liters. What is the final volume if a sample of 4.00 grams of O2 gas is added? So if we come over here, so we know that our formula for Avogadro's law is V1 over N1 equals V2 over N2. So it says, what is the final volume if a sample of 4.00 grams of O2 gas is added? So we need to solve for V2. So you would change the equation to read V2 equals V1 times N2 over N1. So we are given V1, which is 15.0 liters, our initial volume, N1, which is 4.80 grams, our initial number of moles, or our initial weight for the gas, and N2, which is 8.80 grams. Now, the reason N2 is 8.00 grams and N2 is the final volume. The reason it's 8.80 grams is because the problem said to add a sample of 4.00 grams. So you would add 4.00 to 8.00. So if you plug that into your equation, you have 15.0 liters times 8.80 grams over 4.80 grams, or divided by 4.80 grams. The grams will cancel out, so you are left with 27.5 liters as your answer.
According to Avogadro's law, two gases can have equal volumes if they have the same number of moles at standard temperature and pressure, or STP. Standard temperature is 0 degrees Celsius or 273 Kelvin, and standard pressure is 1 atmosphere or 760 millimeters of mercury. Molar volume is the volume. It is 22.4 liters. So 22.4 liters equals 1 mole of a gas.
Okay, now let's solve an equation using molar volume. So this question reads, use molar volume to calculate the volume in liters occupied by 0.420 moles of HE gas, or helium gas. We'll come over here. So the conversion factor for molar volume is 22.4 liters over 1 mole of gas, or 1 mole of gas over 22.4 liters. In this question, we are given 0.420 moles of HE, and we need to find the volume in liters. So we will come down here, and we will use the first conversion factor right here to find the volume in liters. So we will put 0.420 moles of HE times 22.4 liters over 1 mole of HE. The moles cancel, and we are left with 9.4 liters as our answer.
Thank you for watching our presentations on sections 8.2 through 8.6 on the gas law.